The ideas expressed in the following presentations are those of the speakers and do not necessarily reflect the views of ACI or its committees. ACI web sessions are recorded at ACI conventions or other concrete industry events and will be made available for viewing free of charge for 1 week. Thereafter, they will be archived on the ACI website or added to ACI's online CEU program, depending on their content.
Our final presentation today is going to be presented by a group of people. These are people that are members of ACI 369. So we're going to start with the chair of 369, Dr. Wasim Ghannoum from UTSA. And we're going to give you an idea of the ongoing activities within that committee in efforts on how to update the standard and how it will be reflected, hopefully, in also ASC 41.
Sergio, so this presentation is about telling you a little bit about where ACI 369 is, seismic repair and rehabilitation. So we published our first standard, ACI 369.117, and since then the committee has been expanded. We now have 5 subcommittees with the chair names there. I will introduce the committee's kind of work and our relationship with ASC 41, and then each of the chairs that were able to make it, some of us will be doubling up, and we'll be telling you about what to expect in terms of changes for the ACI 369.1 2020. So about our standards. So it was born of a memorandum of understanding between ACI and ASCE. So when ASC took on the ASC 41 standard, they took on the entire FEMA 356 document, sorry. And with that, they took on all the materials. So in that document, there's concrete, there's steel, there's all wood, there's all the materials. Whereas technically, concrete was the domain of ACI and steel was the domain of AISC. So there was an agreement that ACI 369 will now take care of the concrete provision of ASC 41. So all the concrete matters will come to 369, they will be developed there, and they will translate back into ASC 41. So we update these provisions. We published our first standard in 2017 in conjunction with ASC 4117. So the content is essentially the same. That was the agreement. We develop it here, and it goes to their standard. Now, we're coordinating everything, but we have different code cycles. So 369 is going to go on a 3-year code cycle. So our next edition is in 2020, whereas ASCE 41 is on a 6-year cycle. So they will be publishing their next one in 2023. And what I'm going to talk to you about, and what we're going to talk to you about, is what are the big changes you can expect for the 2020 code cycle. So what have we been up to and what we're doing there. Our standards will merge again in 2023. So in 2020, the ACI 369 document standard will be substantially different from ASC 41, and in 2023, all these changes and any additional changes we make will get into the 2020 version. And this is what our standard looks like, and there's also a metric version. So the committee itself, so we've expanded. So we have the one main committee and 5 subcommittees. The main committee has 23 voting members and is balanced according to ACI rules. As consulting members and associate members, we have the general provisions subcommittee. We have the frame subcommittee. We have the walls subcommittee, diaphragms and foundations, and retrofit. I want to talk a little bit about a project that FEMA is supporting. So it is also in the ATC, through ATC. It's a very big project. FEMA is providing funding to update, to make really big changes to 41 and 369. So these are the things that committee members cannot do on their own. So these are very big efforts. Where we met earlier this year, a steering committee, and we decided on the high priority topics that FEMA will be funding. These are listed here: linear procedures, nonlinear procedures, Tier 1 and Tier 2 procedures. What matters to ACI 369 directly is the concrete structural wall provisions. There's also some URM masonry provisions being changed and foundation modeling provisions also. There are big changes coming this way. In the linear procedures, we are looking at the linear procedures from the ground up and seeing how well it does and really updating it. Nonlinear procedures, Adolfo set up this one really well with his presentation. There is serious talk about, for collapse prevention, removing all member level checks and going to more global level checks, so that if one member fails, it's not the entire building that fails. Trying to account for the fact that, one member does not necessarily mean the failure of the building. And there's also, for that, there's increasing member criticality in the deformation controlled function. So there's a lot of things here, but for us here, we're going to focus on the concrete part of things. And ACI 369, just to mention, so this is the project, the structural walls are being worked on within that project, but we're tackling a lot more things in 369, and that's what we're going to present today. With that, I'll open up to Insung Kim, who is the chair of the General Provisions Subcommittee.
Okay, so as Washim mentioned, we have 11 members. We are mainly take care of like the 3 chapters, chapter 1 to 3. Chapter 2 is about like the material properties and condition assessment. And then chapter 3 is more like the general calculation or general estimation of strength and deformability and so on. So we are kind of dealing with not member specific, but more like a general like ideas applied to all other chapters. Currently, we have like 5 or 6 main tasks. First one is like anchor testing and strength provision. So basically, idea is when we have like the existing anchors in the existing structure, when we evaluate this existing anchor capacity, how are we going to do it? So how many samples we need to take, what kind of test method we need to use, and where we need to test. That kind of things are kind of being developed now. It is led by Brian Kehoe in our member. And the other thing is about material strength. When we do the like nonlinear analysis and even linear analysis, ASC 41 has like the 2 actions. One is like a force controlled action and deformation controlled action. And then deformation controlled action, we use like expected strength. And in ASC 41 definition, that's the mean of the strength, mean from the test. And then we have lower bound strength for the force controlled elements or force controlled action. That is like the lower bound strength, which is typically corresponding to nominal strength. So we need to kind of work on, like Adolfo is leading this effort, and how we gonna kind of set up this like a lower bound and expected strength correctly, more adequately. Like I have another slide for that. And then also effective stiffness. Like when you do the either linear or nonlinear analysis, like you need like effective stiffness of members, and then that's what ASC 41 has like the table, and our standard 369.1 has a table, table 5, showing this like a reduced effective stiffness from the gross stiffness. Like that, we will try to update that values. And the other thing is like a nonlinear dynamic procedure. So in practice, we are using nonlinear response history analysis to evaluate this existing buildings a lot. But ASC 41 was developed actually for the pushover analysis. So there is kind of lack of information, like hysteresis shapes and so on. Like, so we try to update this procedure with other like modeling methods, like fiber modeling. And last thing is like shear friction. Like our standard requires to use like the 318 14th like a shear friction model, but we have some issues, so we apply this thing to like existing structure. So we are working on that right now. And so one of the things we are working on that Adolfo is leading this effort, so lower bound and expected strength. So right now, like for example, for the steel reinforcement, we have just one factor, 1.25, which is kind of converting nominal or lower bound strength to expected strength. And then now we are thinking about what that number actually needs to be. Like that 1.25 include actual overstrength of yield when you test it, and also include a little bit of some of the like strain hardening effect. And then we try to kind of separate that and then put it as two separate factors, for the one for the actual overstrength and the other is for the strain hardening. And then also we are considering implement like dynamic increase factor, which is kind of considering strain laid effect. So that's a SIF for the overstrength of the yield and strain hardening, and then DIF for the dynamic strain laid effect. And then also, like we are trying to improve like nonlinear dynamic procedure, kind of using the recent studies from ATC 114 projects and then on other projects. So basically, we try to kind of provide more guidelines how when people do the nonlinear response history analysis, how model this hysteresis, based on the our knowledge from the test data and this kind of projects. So that's pretty much what I have.
Orders from the boss to do it quickly, so we'll go as fast as we can. We are the purview of 369 sub C is the chapter moment resisting frames. So that would be section 4 in the document. And as I was mentioning, the concern is we've made a lot of changes to the column provisions. We want to update all the other elements to make sure that we're being consistent throughout. We're not being, at least in the modeling, we understand the different levels of safety that should be had when we're judging acceptance criteria, but in the modeling we should try to be agnostic. We should try to represent each member in what it does. And so we're going to be working on beams, slab column connections, and joints. I'm going to describe, for example, for beams, we're looking at updating modeling parameters and eventually acceptance criteria. In the case of slab column connections, this is the work that is being done by Mary Beth Husty from Texas A&M. You see here in her graph is total drift demand versus gravity shear ratio. This is very typical in the simulation and evaluation of these types of members. And what she's done is she's collected a database and is trying to provide, for example, the green line is what she's doing, the black line is what 318 does today. 318 for new design adopts a very conservative approach. For the purpose of modeling, we're looking more for a mean approach so that there's no bias between beams and columns. In regards to joints, we're trying to take a close look at joint capacity equations. We think that those need some revamping. We're going to look at modeling parameters and acceptance criteria. And I think in Laura's presentation, there was a small thing that is extremely important, is I think we need to provide better recommendation about what to do. I mean, there's that simple model that is in ASC 41 now. The way that it is written in the provisions is only applicable to linear analysis. And so we think the code is silent on what to do with the joints in nonlinear analysis. And we're trying to listen to designers in the sense that in many instances the joints are not going to be the critical factor. So if we can then look for simplified ways to model the joint with the joint nonlinearity is not critical in a nonlinear analysis, that makes the nonlinear analysis less painful. So we were trying to develop recommendations for that. And that's it for me.
I'll speak on behalf of Garrett Hagen. He was not able to come here. He's traveling overseas. He's the chair of the Wall Subcommittee. So we're going to give you a little bit of overview of what we're doing. A lot of this effort is handled by the ATC 140 project, but there's a lot of cross membership between the project team and the subcommittee. So it's we're going hand in hand in this project. So the working group is looking at really wholesale updating the wall modeling parameters and acceptance criteria, so big changes to be expected for the 2020 version. The wall provisions, we have the backgrounds reads, we haven't updated them in a long time, so specifically the flexural ones, we consider them, or generally consider that they're quite conservative and they're inconsistent in conservatism and accuracy. I'll just, the animation, these are his slides, I'm trying to do them justice. So currently what we have is an opportunity, Professor John Wallace, who's also a member of the committee and of the task group, has populated a 1,000 or so wall test database with Saman, who's sitting here. He did all the hard work. And so we have an opportunity now to come in and really change the wall provisions. Also, things we're trying to address is limited modeling guidance. Most of the engineers use fiber sections for walls, whereas ASC 41 or ACI 369 are written with only lump plasticity. So how do you go from one to the other? How do you get to the right acceptance criteria with a fiber section model when it's given to you as a lump plasticity thing? There's also things that are missing. There's no cyclic guidance, which we will be tackling. There's inadequate lap splices. We only have the column provisions. We're trying to translate them to the wall provisions. There's also things like no real guidance for what do you do with a single curtain wall as opposed to a double curtain wall. Also, non-rectangular shapes are not really treated. In addition, looking at coupling beam issues, so similarly, they have not been updated for a long time. There are some very conservative parameters in there. So also things like what is collapse for a coupling beam? Do we really need to worry about the coupling beam collapsing? Or is it just treated as a loss of lateral strength for the building? And also nothing much about diagonally reinforced coupling beams. We also have things about the stiffnesses being a little bit too high for our taste. So, okay, one last thing. What to do with a slab? Also, there's nothing about what is the performance of a coupling beam that is framing into a slab section. So the objectives, I kind of mentioned them as I was going through. We're going to revise the modeling parameters and acceptance criteria for the walls. We are going to give full modeling response guidance, so including cyclic behavior. So this is going to be new NASC 41, ACI 369. This is the first member where we're going to put cyclic guidance in there. And we're going to look at everything from deformation capabilities, strength equations, splice and anchorage, even sliding at the base of the wall. And finally, we will update the linear acceptance criteria. So a lot of changes. If you're not happy with the wall provisions, wait 2 years. In 2020, there is going to be a lot of changes there, including cyclic behavior. With that, Insung, you're presenting for Arne. Arne also was not able to make it. All right.
Arne could not make this event. So, oh yeah, this is what is calling like a diaphragm foundation, so like a length of the leader. Yeah, so you might saw that like this committee has only 2 members, so we are still looking for the people to have this committee. The problem is, I think there are not many people actually interested in this committee because we don't really know much about diaphragm and foundation. So currently, ACI 369 and ASC 41 has very conservative provisions of diaphragm and foundation, like because we don't really know much about it. And sometimes we ignore it in our design, but it is very important, like load pass components, like when we're dealing with lateral load. So basically, Arne is kind of working on identifying typical problems in diaphragm, just like a slab to wall interface, like it is kind of related to the 369A, like general committee, like shear friction issue, and then precast concrete diaphragm problem with frame elongation. You might see the Ken Elwood's presentation about the statistic house building in New Zealand. When earthquake happens, like a beam is elongating, and then like hollow core, like the panels are kind of just unseated and then collapse. And then also lamp and stairs. He is kind of tackle how to deal with lamp and stairs in the lateral system. And also like some modeling of the diaphragm, like either simple beam model, like a membrane model or finite element model or strut and tie model, like how we can model like diaphragm behavior more reasonably. And also he is kind of working on the like foundation, like here we are specifically called footings, like concrete foundations. And all components of existing foundations shall be considered as a force-controlled action. That's kind of issue. So basically, we are, because we don't really know much about the concrete footing or foundation behavior, like these actions are considered as a force-controlled. So that's kind of we have, like practitioners have some difficulties which end up with unnecessary retrofit of foundations. Yeah. So that's pretty much it.
And you start with me, you end with me. I'm the chair of Subcommittee F, the Retrofit Subcommittee, and we're in charge of providing information on retrofitted components, how to model them and treat them. Currently, the ACI 369 standard does not contain any information on retrofitted components. So what we need to do is we need to add information on all of these items that pertain now to components that have been retrofitted in an existing building that requires retrofitting. So we need to add material properties. We're working with data. So in order to make our task achievable within the next 3 years, we chose jacketed columns as the first component that we're going to be tackling. And we need to provide the data that's listed there in the slide, including material properties, working on an existing database that we have to determine modeling parameters, and provide recommendations to the user on how to determine strength of retrofitted components, and try to come up with reasonable acceptance criteria that also matches what other subcommittees are doing. This is the shape of the backbone curve that we're proposing. You've seen this before. I won't dwell too much on this slide. And these are some of the items. This is an example hysteresis curve that was obtained from the database and how we have extracted some of those modeling parameters. And with those, we have created a probability or fragility curve, say, for one of those parameters. And this is just for a sample of FRP jacketed rectangular columns. And we're going to try to provide some, the 50 percentile parameter that makes sense to construct tables that look like this, so that these can be incorporated into the next revision of the standard, where we have items like the type of retrofitting techniques such as FRP or steel jackets, the shape of the column, circular or rectangular, and the different levels of axial force. And again, consistent with the rest of the standard, what are the modeling parameters that correspond to this type of element? I realize I'm flying through this. This is my last slide, and this concludes this session. Thank you for attending. I'll put up the code in a second. Will eventually be doing looking at retrofitted walls. The approach we decided to follow was to proceed with 3 levels, what we thought we could achieve within the first 3 years, realistically. And then once we have those provisions in there, let's say for jacketed columns, we are now in the process of collecting information for walls that we will eventually incorporate into the standard.